All right. Thanks for joining us today. We are super excited to spend some time talking about best practices for spreadsheet structure, what those practices are and why they're important, but also how you can totally disregard them and build more agile and stronger models in the end. I'm Lyndsey Weber, Solutions Consultant at Quantrix and recovering spreadsheet modeler, and joining me is Brad Hopper, Quantrix General Manager.
Hi everyone, we're glad you're here.
So we're going to talk about why structure is so important today and give you some tips for improving the structure of your spreadsheet models. But we're also going to tell you about an alternative approach using a dedicated financial modeling tool that has built-in structure. And along the way, we'll sprinkle in a few customer stories so you can understand the business benefits of a structured approach. So what is structure and why is it such a key consideration when building spreadsheet models? Well, we could boil down structure to mean the overall organization or architecture of a model. It's what we build into a spreadsheet to give it order and consistency and reliability, and another key factor for scalable models, which is dimensionality. The distinctive look of a spreadsheet is that sea of cells, rows, and columns. Like a blank canvas where we can do anything from plan our next vacation to tracking the budget for our small business, all the way to what some of you may be building, enterprise-level financial models and forecasts. Spreadsheets are extremely flexible, but they can also grow fragile over time as our models grow in size or complexity. And so without structure, that point of fragility comes a lot sooner. If you're in finance or logistics or even HR, it's likely you have a model or a series of models that you work in all the time. In fact, what types of models do you work with? We'd love to know in the comments. And having an organized, repeatable approach for building and using these models is essential to make your work efficient and to minimize the chance of errors. Structure becomes even more important when these models need to be handed over to new users to manage. So a clear understanding of how the model is put together is crucial. If you're in private equity or venture capital or investment banking, structure is a requirement. If investors can't audit your model's calculations and confirm that your outputs are correct, you could miss out on opportunities or even face legal consequences when mistakes are made. Finally, structure is so important because for most things we're building in spreadsheets, we have more than 2 dimensions to our model. But spreadsheets are by nature flat. So if you're running the cash flow forecast for a global company with multiple products sold across maybe a dozen regions with numerous sales channels and projected out 5 years, you're going to need to construct your model with these dimensions of your business and define the relationships between all these things. So structure in models is critical, but 2 facts about the very nature of spreadsheets are working against us. Fact 1 is that cell coordinates and orientation matter. Every cell in a spreadsheet has its own unique set of coordinates, its row number, and its column letter, and the orientation of our data will often determine the type of formula we have to write, especially when performing lookups. Fact 2 of spreadsheets is that values and formulas reside together in cells. The basic concept of a spreadsheet requires the value of a calculation to live in the same cell as the formula itself, which means we have to be very careful about how we designate our model's logic, inputs, and calculations. Both of these facts are in the DNA of spreadsheets. We can't change them. So we're going to talk about a few classic structure best practices that might help us work around these constraints, but you may have some of your own you'd like to share, and if so, feel free to throw them in the comments as we go along. We'll pause just one more time here to say there are probably dozens, if not hundreds, of spreadsheet best practices, all of which can help us maximize the value and agility of our models. In this webinar, we're just going to cover a few of the basic best practices that are most commonly implemented across a variety of spreadsheet models. Our flow here is going to look something like this. We'll introduce the best practice and the key benefits your spreadsheet will get from it. We'll be using some spreadsheet templates from Microsoft Excel that incorporate these best practices as examples, so you could explore more on your own after the webcast. We'll also tell you about a couple of limitations or downsides associated with these spreadsheet practices, and then show you another way to get the benefits of the approach, but without the downsides. And for that, we'll be using Quantrix to illustrate, and you can explore more on your own using our free trial. All right, let's dive into spreadsheet fact number 1. Focusing first on our spreadsheet fact that cell coordinates and orientation matter, this one is so important. enforcing consistent naming among various locations in your spreadsheets. In order for lookups across sheets to be successful and reliable, we have to enforce consistent naming, whether that's through copying and pasting across tabs, or perhaps you just prefer to index the row numbers for your lookups. But getting this detail right the first time will save heartache and headache when you go to validate your lookups or returning the expected value. Similarly, it's best to decide early what the primary orientation of your data will be across your model. Especially for financial statements, keeping data or line items in rows and formulas consistent stretching from left to right across time periods is going to enable easier pivots and more auditable formulas. Let's take a closer look at consistent naming. This is a simple one to follow, but it's easy to get complacent or make a mistake, especially if a new line item or account is added to your business. We have to ensure that the new item is added everywhere. As an example, ensuring that your travel line item or a new expense item is reflected in both the cash flow and the budget sections of your model is paramount. The downsides of implementing this best practice are: 1, it's an exacting job to ensure you keep everything consistent in your model, and it can get repetitive unless you're writing a macro or taking very careful note of your named ranges and tables. It's also easy to make a mistake in spelling. We have to take the utmost care if we intend to just copy and paste these items across our spreadsheet. Finally, connecting back to pivot tables. While keeping everything in a single orientation, let's say rows, in our model is clean and simple for the user to learn, if our users want to see the data in a different orientation, we'll need to create a pivot table or copy this sheet and reconfigure it entirely, which again is adding more tabs to our model overall. And coming up, Brad will show you how we avoid all of this copying and duplicating using Quantrix. Reinforcing this thought of deciding the primary orientation of our data, you can see on the right in this cash flow example that the formula running across the total cash available row is nearly identical, other than the changing month. The downsides here are: 1, that we still have to pinpoint for every formula that we're wanting the same month referenced for our cash on hand and total cash receipt. Secondly, as the timeline in our model extends, we're going to need to take care to ensure that our formula for total cash available and all the other rows is extending properly for us. We've got just 2 final points to make about dealing with cell coordinates and orientation in spreadsheets. This first one is arguably one of my biggest pet peeves in spreadsheets. As much as possible, avoid non-tabular layouts and merged cells. Non-tabular really means lots of levels of rows, or column headers, or groups of cells that are meant to reflect a hierarchy. Usually, when we're merging cells or creating these kinds of layouts, it's completely for looks and presentation. But when we do this, we make it a lot harder to use the data in different ways. Avoiding merged cells is going to simplify pivot table creation and also make formulas easier to write. Our last point is often the last step we should take in completing a spreadsheet model, and that's building in a section of the model to perform validation checks on all of our work, just in case we made a mistake or forgot to implement any of these best practices we're talking about today. Here's a lovely gallery of merged cell errors that you might have seen, although I hope not for your sake. We'll keep this one super simple. Just don't merge cells, or keep a separate tab for your presentation layout, but a flat tabular version of your data tucked away for use in calculations and pivoting. Building in calculation checks is a really powerful way to audit your formulas and help others check your work too. On the right is just one example of how you might go about validating your model for completeness and accuracy. Having a detailed item level or sheet level review of your most important calculations with a roll up to the summarized level can give you an at-a-glance look at your model's health. In this example, we're checking that every year and month has a value for the balance sheet and P&L items, and we're also confirming that the closing cash values match on the balance sheet and the cash flow, and that the annual totals equal the sum of our quarterly totals across sheets. So what's the downside? Well, one is that just building this sheet is quite an effort and requires another layer of complicated formulas to perform the validation for us. And if any checks return red, we'll still need to put on our investigative hats to go back through and trace the loose threads to find the cell culprit. Then, of course, if we haven't used name ranges, that investigation will be quite a bit of translating between our desired calculation and those abstract alphabet soup formulas. At Quantrix, we sometimes call them battleship formulas, like the old board game. Things can explode if you get the wrong coordinates. And that brings us to our first Quantrix show and tell solution. Here's Brad to show us how we can get consistent naming and simpler formulas without the ongoing maintenance.
Thank you, Lyndsey, for sharing how important cell coordinates and data orientation can be when you're trying to build a robust model in a spreadsheet. I do want to take a few minutes now, though, to show everyone an alternative approach that we think might help to alleviate some of those downsides that you mentioned. Quantrix is an agile business modeling technology that was designed specifically to solve these kinds of challenges. In this demonstration, we're going to put together a model for our business that forecasts, at the regional level, the sales and unit growth of our company. Importantly, in this first demo, we're just going to prototype the structure to explain some concepts, and then in the demo section after this one, we'll add in our actuals data and show you how you might share this with others in your organization. I'm starting almost from scratch here, but to save some time, I created two matrices, one to hold the forecast itself, and one for our regional growth rates. There's not much in that one at the moment except a base rate in our scenario category. Now for the forecast, I've got a category called products down here that contains a list of items, which are in this case my favorite desserts, and some randomly generated dummy data for sales in the first of 5 years. Now I said regional forecast, right? But we don't have that yet, so I'm going to click this plus sign to add a new category and call it regions. You can see the first region is created by default, and now let's change the name to North, create South, and so on. I'm going to move regions in front of products to set up our little hierarchy. And now right away we've eliminated some of those spreadsheet downsides. Number one, every product is now appearing in every region. And because we don't have to type or copy them, there's no chance of making a mistake. Furthermore, in spreadsheet terminology, you might say that the cells for region have been merged, but in reality, we don't need to merge anything because Quantrix is by nature multidimensional. It's just displaying the data in a convenient way. We now have 3 dimensions in our forecast: regions, products, and years. So let's get to forecasting. We're going to make our first new formula where we want this year to be the previous year times, let's say, 2. You can see what happens above. Every cell is filled with the results of that formula across the matrix into our future years, and we're doubling every year across all products. The desserts are proliferating. So now, how do we get started with those regional growth rates? Well, the first thing I want to do is establish a relationship with the existing regions. All we have to do is drag the region category across and replace the default category in the rates matrix. Notice that we inherit all the regions automatically. Here's another example of how we've eliminated the possibility of error and don't have to worry about naming and lookups. Because we have this relationship, anytime a new region is added, or anytime a name is changed, all linked matrices will be instantly updated. Linking categories in this way is even more powerful than that. As you'll see, they dramatically simplify our formula writing. We'll tweak this formula so that instead of doubling every year, we multiply the previous year times the growth rate scenario. We could type it in or just click it like this. Quantrix will use the linked category to automatically look up and use the correct rate in the formula. So not only do we not have to worry about naming errors, we don't even have to write the lookup formula at all. Lyndsey mentioned that in a spreadsheet, you might want to establish an orientation standard so that these lookup tricks can work. But that approach might limit your flexibility to display the data. In Quantrix, that's not the case. We have always-on pivoting so that any data can be rearranged any way you like, and even different viewers can have different ways they want to look at the same data without impacting how the model works. Finally, if we want to double-check that this formula is doing what we think it is, Quantrix offers a super fun and valuable tool called the Dependency Inspector. Clicking on any cell, the Dependency Inspector will show us which other cells are referenced in the formula and how each part of the formula evaluates. We can even navigate backwards and forwards in the computation graph. We could have a whole webcast on just this feature. Is the Dependency Inspector your favorite part of this demo? If not, tell us what is in the comments. All right, before we go back to Lyndsey for more best practices, I want to share a quick customer case study. Many of you might be working in traditional finance, But Quantrix is just as suited to operational use cases, either standalone or in true S&OP mode, bringing finance and operational modeling together. Let us introduce you to an oilfield services provider who uses Quantrix. Although you probably wouldn't recognize their name, this company is one of the few service providers in the world who can tackle the extremely complex job of ocean bottom seismic surveys that help oil companies to find the right places to build rigs and drill for oil. Before Quantrix, they were managing extremely complicated pricing and quoting information in spreadsheets to help them estimate multi-million-dollar projects and returns on investment. These projects involve specialized people talent, hardware, software, leasing, insurance, and consumables like fuel, both the ship kind and the food kind. They told us that a single calculation error or mistyped assumption can cost them the entire margin on a multi-million-dollar project. Having experienced six-figure losses in the past from such errors, they eagerly adopted Quantrix's linked structure to dramatically reduce the risk of lookup mistakes, incorrect constraints, costs, and assumptions for every vessel in a fleet assigned to every project. From an operational perspective, things can change in a project at a moment's notice. And if a crew was delayed at a port or a piece of machinery malfunctioned, historically analysts would have to scramble to update the spreadsheet model to take into account the new cost disruption. This would often take several hours, if not days, which would be too late to recover and pivot the project to account for the cost. Now, new costs, timeline implications, and new scenarios or alternatives can be added to a project with just a click, since business logic is automatically extended throughout the model when a new scenario is added. Now back to you, Lyndsey.
Now let's talk about our second spreadsheet fact. Values and formulas reside together in cells. Let's introduce our first best practice, which is to keep actuals or raw data separate from the modeling and input areas in your model. So this is all about organization and separation of function. The key benefit here is that this practice helps protect your model from accidental overwrites or value changes, especially if your model is being used by multiple people. This point also relates to model security, and we won't cover that in this webinar, but having separate sections of your model might be a way to help restrict access to different portions of your model for different users. Using named ranges and tables in your spreadsheet will greatly improve the readability of your formulas. Instead of referring to cell coordinates alone, ranges help bring context to your formula logic and will not only help with auditability, but can also provide benefits when your model extends, as ranges and tables can be dynamic and actually grow to include new rows or columns. Finally, pivot tables are arguably one of the most powerful features of spreadsheets. But it's really important to provision enough breathing room around each pivot table so as your model grows or your pivot tables update, they have free space to do so. Keeping pivot tables on completely separate tabs or at least spread out by a few rows and columns will help you avoid pivot table errors like overlaps. We've all seen in the news how spreadsheet errors can cost companies millions of dollars. And oftentimes, it's the simplest mistakes that are the easiest to make, such as copying data over an existing formula or failing to provide that separation of raw data, assumptions, and calculations. So when we talk about separating our model into sheets for different functions, often it can look something like this: an individual tab for actuals or raw data, a dedicated sheet for inputs and assumptions, and separate sheets for core calculations such as forecasts or financial analysis. A few of the downsides to this best practice is you can quickly grow a model from a couple of worksheets to dozens, which can be really difficult to manage and also disorienting for other users to learn and navigate. And as you add more sheets to a model, it also adds more work to ensure the security and permissions overlaying the model are up to date. By the way, if you ever want to see data from two worksheets in the same view, you can't do that without launching multiple copies of Excel and doing Windows tricks to compare across them, which can also get hard to manage. Looking back at named ranges, you can see in the table on the right that the formula for the monthly forecast utilizes the names of a forecast input table and its columns. This makes the formula much easier to read. But a few downsides to named ranges and tables are that 1, they take a bit of time to set up and you have to take care to name your tables specifically and accurately in order for your formulas to actually be clear. Similar to the previous point about worksheets, it's easy to proliferate tables and named ranges in your model, and often users will create a designated sheet in their model just to store these lists or named ranges for easy reference. Finally, even named ranges can't completely eliminate the need to use cell coordinates in a formula. Unless you're willing to put in the time to designate a name for every cell, you'll likely continue to have cell coordinate references in your formulas, which take more time to validate and audit. Finally, pivot tables. Once you're comfortable using and creating pivot tables, it's easy to get carried away creating pivot tables constantly, either for ad hoc analysis or data validation. But be cautious of putting too many pivot tables in the same sheet, or you can end up with an overlap error, kind of like what you see on the right here, where your pivot table has expanded and is now encroaching on another pivot table nearby. We can avoid this by putting pivots on separate sheets, or even waiting to the very end of our model building to create these pivot tables. But here are the downsides. As your model expands, you're going to have to continue to clean up and maintain any existing pivot tables you've built, or perhaps delete and start all over again. We're still proliferating tabs in our worksheet here to get the pivot table separation. Finally, oftentimes we get carried away with pivot tables, or we want to see the same pivot table in a different orientation, which means we're likely duplicating data in our pivot table cache, which can quickly blow up the amount of data stored in our model. So we've covered some best practices associated to the fact that spreadsheets keep values and formulas stored together in cells, and some of those related downsides. How do we get the benefits of the best practice without the risks? In Quantrix, we'll show you how we've built in these best practices directly into the tool so you can forget building and maintaining them on your own.
Thanks, Lyndsey. Let's take another look at this simple demo model. I didn't point out earlier the somewhat obvious fact that we can see both the forecast and our assumptions matrix at the same time and observe the impact any changes will have. That simplest interaction is actually difficult to pull off in a spreadsheet without violating the best practice of putting your assumptions on a different worksheet from your calculations. In this case, we only have 2 matrices, but if we had 200, along with charts and canvases, it's easy to organize and navigate them over here in the Quantrix model browser. Another point to make is that every one of the cells in this forecast prototype is computed by just these 2 formulas. The cells in the matrix are free to contain results only. They're not overloaded by formulas, and the formulas inherit the structure, so we don't need to worry about where to physically put things. Finally, because accidentally editing a formula in a cell is such a common and dangerous error, no matter how many times I put my elbow on the keyboard, Quantrix just won't allow these cells to be edited. We can override these values, but that's a demo for another day. All right. Let's take our prototype to the next level by bringing in some actuals data. First, we need a place to put the actuals data. We can easily extend this matrix by creating a new category called type. The first item, what we've been setting up here, is the forecast, and we can add a second item called actuals. Now notice these formulas are doing their work in both the forecast and the actuals area here, but there's an easy way to fix that. We can literally tell the formula to skip the actuals and restrict its scope to only the forecast. And we'll do that in both formulas. So in Quantrix, essentially everything is a named range. All of our data has a named place to go, and we can refer to that data using its name in formulas. This, together with the linked categories we saw earlier, means that our formulas will tend to read in natural language, no lookups, no index matching, and no battleship coordinates, etc., making them easy to write and easy to understand. Then, using the dependency inspector we saw in the last demo, anyone can audit formulas in a super effective way. Now, let's make a connection to a database. I've got one here called Superstore21, and we'll bring that data into our model. Now, Lyndsey described the best practice of keeping your actuals data separate from your calculations. We could easily do that, but it's not required. We can also directly merge the actuals into an existing matrix. I'll choose the forecast matrix from this list. We can pick the subcategory field from the database as our products, and also use region as our regions. And then when we drag the sales and units numbers in, Quantrix will ask us where we want to put the results. The default is the first year, 2021, and we can pick that actuals item that we just made. When we accept this configuration, voila, in comes our data. Now, there's just one more thing to do. Instead of this random data as the starting point, we want to use the first year of actuals as the baseline. So we can tweak this formula one more time and say, in 2021, the forecast equals the actuals. Super simple. Obviously, we don't have actuals for future years, so we can just hide those empty cells and make our matrix cleaner. But still, there's a lot of data here. What if we have multiple people in the team and each one wants to look at only their own data? It's very easy to configure personalized access to this model such that if we change our role to one responsible for the central region, we'll only see the data we need to analyze. Now from here, it's just a matter of a single click to publish this model as a web-based application that others can use online and put in their inputs and do their own analysis. I hope you can see that we've showed you how to avoid the downsides of most of the spreadsheet best practices that Lyndsey called out. If you've seen anything in this demo you think you could use in your business, please let us know in the comments. We'll be tackling as many questions as we can, so check back later for answers. Now, before I hand it back to Lyndsey to conclude, I want to say a few words about a global manufacturer and retailer who's used Quantrix structure to great advantage. It's likely you've used this company's products if you've ever ridden a bicycle, or if you have kids or a younger brother or sister. With multiple brands, hundreds of product lines, thousands of SKUs sold into many international regions through multiple distribution channels, as you might imagine, creating and managing a monthly forecast is quite an effort. Not to mention the work and risk involved in creating a new product or adding a new channel. This customer enjoyed the scalability of their existing enterprise planning system, but was struggling with how much human effort, time, and programming was required to make changes or to do what-if analysis on the fly. They attempted to use spreadsheets to gain agility, but maintaining the structure and process was just too onerous, and the performance was not acceptable. So they switched to Quantrix, and now they have real-time forecast input capability for their team across the globe, who can be making updates and changes simultaneously and see the results instantly. The inherent structure from Quantrix-linked categories and grouped items handled their complex hierarchy needs and simplified calculation with real language formulas, as we talked about earlier. Also, the teams each had their own preferences on how they wanted to view the company's extremely hierarchical data and product set, and Quantrix gave them that ability while removing the risks they once had in managing hundreds of pivot tables in offline spreadsheets. All right, Lyndsey, back to you.
So you're probably thinking, a lot of these best practices are built into other tools too. And you'd be right. Two of the most common alternatives companies consider to solve their spreadsheet woes are add-ins and enterprise planning tools. The downside to spreadsheet add-ins is you are still constrained by the two facts we've been talking about all hour. We can't change the rows, columns, and cells design of spreadsheets. We can only build on top of them. So many look to enterprise planning tools to help them scale up their existing models. And this might be the right tool for you, but it comes with careful consideration and weighing of the implementation cost and time, and your organization's willingness to rely on continued support from consultants to maintain and retool the solution on your behalf. Comparing spreadsheets and add-ins to enterprise planning tools in Quantrix, we can evaluate them based on their built-in agility, scalability, and structure. Spreadsheets are incredibly agile, but as we've discussed today, scalability can waver with complex models and structure must be created entirely from scratch. Enterprise planning tools aren't agile and are often limited in customizability by the user, but they are very scalable for large companies with complex businesses. These tools have built-in structure, but as mentioned, it's often out of the box and may not perfectly reflect your business without paying for consulting help. Quantrix checks all three boxes here with its flexibility and fully customizable structure that gives you complete control to build what you want, with the best practices included, so you can focus on modeling and not maintaining. So here's the wrap-up of the best practices we've presented that are do-it-yourself in spreadsheets, mapped directly to the Quantrix functionality that comes out of the box. The separation of logic and values is directly wired into the Quantrix application, and real language formulas combined with automatic ranges means every formula is readable and auditable. Lookups and spelling consistency come pre-built too, with the ability to just drag and drop model components across matrices to inherit identical spelling and linked relationships. This is what makes it possible for any user to slice and dice the data in any direction without fear of formulas breaking or encroaching on other portions of your model. Even and especially complicated multidimensional data sets are where you capture the full power of Quantrix, since adding new dimensions or timelines to your model is simple. And while the building process is much more intuitive in Quantrix than a spreadsheet, since Quantrix does most of the legwork for you, we've built in auditing and logic viewing tools so you can drill down to any detail of your model to check dependencies and mid-calculations. Here's the final recap of what Quantrix enables modelers and planners to do. Connect to a variety of data sources and incorporate your business's unique assumptions and drivers to build forecasts quickly at the speed of change. All of this while leaving behind so many of these DIY spreadsheet best practices and their downfalls. You can model in Quantrix without consideration of cell orientation and without fear of low performance or insufficient governance. You've seen just a little bit of what Quantrix can do, so what questions do you have? Drop your questions in the comments and we'll reply right here. You can also explore on your own through our website. Check out our product videos, other customer stories, and even test drive the product for yourself with our free 30-day trial. Don't forget to check us out here on YouTube for other videos and follow us on LinkedIn and Twitter. We hope that this webinar has given you some helpful pointers or a good refresher on the important structured best practices to incorporate into your models, and maybe has sparked some curiosity on whether spreadsheets are the most effective, value-added tool to use for your complex models and forecasts. You can also connect with me or Brad on LinkedIn and send us a message if you want to discuss your use case. Thanks so much for joining.